Hey, Algebra 2, today we are going to learn how to graph exponential functions. So the parent function is in the form y equals b to the x. And so right now we are going to graph y equals 2 to the x. So that means b equals 2. That'll come to mean something in a minute. So I say we just start with a table of values. And when we want to graph something, usually going from -2 to 2 is the best thing. So it's probably been a while since you've done 2 to the -2, but you could stick it in your calculator. Otherwise, you have to remember that 2 to the -2, if you have a negative exponent, you flip it and send it down to the denominator. And so that's why it is 1/4. So 2 to the -2 is 1/4. 2 to the -1 is a half. 2 to the 0, anything to the 0 power is 1. 2 to the first is 2, and 2 to the second is 4. So this is what I'm going to graph. -2, go up a little bit. -1, go up a half. 0, 1, 1, 2, 2, 4. All right, so it seems to be kind of flat right here, and then it's going to get really steep and curve. So this is what an exponential function of 2 to the x looks like. We read a graph from left to right, and so it starts off really flat, and then it gets bigger and bigger and bigger. So this looks like it increases. So it's an increasing function, and when you have an increasing function, we are going to call that a growth function. Domain, you have to remember domain are your x values that you're allowed to use. So domain is your x. And I can plug any number in for x that I wanted to. I plugged in both negatives and positives. So I could say it's all real numbers. We typically write it in interval notation. And all real numbers goes negative infinity to positive infinity. Your range is your up and down. So it gets real big. It's going up here to positive infinity. It's definitely doing that. But it's not going down here to negative infinity. It seems to be approaching this x-axis right here, but it's never going to reach it. It keeps getting like, goes down half, down half, down half, down half. And so when you keep going down by half, you will never approach it. You will come really close. But this range is actually y is greater than 0. And in interval notation, we would say that is 0 to infinity. An asymptote is a line the graph approaches but will never cross. So it seems to be approaching this x-axis. So I'm going to draw in a dashed line there, and I'm going to label that my asymptote. This right here is the line y equals 0. So I have an asymptote at y equals 0. If I have an asymptote at y equals 0, that means I'm never ever going to cross the x-axis. So I don't have an x-intercept, but I do have a y-intercept. And the y-intercept is kind of a big deal. I have a y-intercept right there at 0, 1. So that is how you would go about graphing a function. And let's do it again. This time, our b is a fraction, 1/2. So this time b equals 1/2. Well, let's just start with the table of values and plug some numbers in and plot some points and see what it looks like. -2, -1, 0, 1, 2 are some good x values to use. So if I have x equals -2, that means I have 1/2 to the -2 power. There's a lot of negative exponents that go on here. It would be easiest if you would put this into your calculator exactly as is. You have to include your parentheses to make this come out right. So go parentheses. I would use your ABC button if you don't have the fraction button on your calculator. Raise to the -2 power. And your calculator should say 4. If you put in 1/2 to the -1 power, your calculator should say 2. If you put in 1/2 to the 0 power, anything to the 0 power is 1. 1/2 to the first is 1/2. And when I take 1/2 to the second, that means you have to distribute it and you square both the numerator and denominator. And that gives you 1/4. All right, so I have -2, 4, -1, 2, 0, 1, 1/2, and 2, 1/4. All right, so this seems, okay. I also know I'm going to have 3, 9 on there, just because I've done it a few times, so that'll give me a better point. And I am trying so hard to match up my dots. All right, that's pretty good. So that is what your graph would look like. So it starts up high on the left, and then as you go down, it seems to be decreasing and getting smaller and smaller and smaller over time. So this is a decreasing function, which we are going to call decay from now on. So if it's increasing, it's growth. If it's decreasing, it is decay. Your domain is your x values. I can plug anything in I want, negatives and positives. So it is all real numbers. In interval notation, I would write that as -infinity to positive infinity. That means you can have anything you want. Your range, you have to remember, are your y values. So it measures your distance up and down. So this is going up here to positive infinity. And then over here, there is also an asymptote, and it seems to be approaching the x-axis, but it's not going to cross it. I also have an asymptote here at y = 0. So my range is y is greater than 0. In interval notation, I would write that as 0 to infinity. We talked about the asymptote already. So I have an asymptote at y = 0. And once again, I have no x-intercept because of my asymptote. But I do have an y-intercept, also there at 0, 1. All right. I'm afraid the backside is going to get longer, so I'm going to hit pause and continue the backside on a new video.